Hello and welcome back everyone. Throughout the upcoming sessions, we are going to use few words such as 1D, 2D and 3D meshing frequently. Though we will take a deep look into most of the aspect of this meshing type, I felt it is necessary to give you the little idea about the fundamental difference between 1D, 2D and 3D meshing. So without further delay, let us begin. As I just told you, there are three different type of elements, or we can say there are three different type of meshing approaches, which is 1D meshing, 2D meshing and 3D meshing. There is a fundamental difference between all these three type of meshing. Before we understand the difference between the 1D, 2D and 3D meshing, first it is very important to know that in all this type of meshing, one thing we have to make sure that we are representing the volume. And with volume, I mean to say we have to describe all the three dimensions of the component in the 3D space. So it does not matter whether we are using 1D, 2D or 3D. At the end of the day, we have to define the three physical dimensions. Then, depending upon the approach, how we are going to define those three dimensions, that is definitely going to vary. So let us take a look into first meshing type, which is 1D meshing. Generally, whenever we have the one dimension very large as compared to other two dimension, then we can use the 1D meshing. Currently, here you can see a single black line has been drawn and just in front of it there is a rectangular cross section. So basically that length of the beam is very high as compared to its cross section dimension. Then in case of meshing, we just have to define the two nodes. In those two nodes we are going to create a simple line, and to that line we are going to apply the cross section. So here we understood that 1D meshing is generally useful when one dimension is very large as compared to other. But the question is how larger it has to be. So there is a standard thumb rule. Generally, the ratio of the largest dimension to the smallest dimension, it should be greater than 10. In that case, we can use the 1D meshing. As discussed in the beginning, to start with the 1D meshing, you just have to create the two node and create the line between the two nodes. With the 1D meshing, we have created a simple line. That means we have defined one dimension. But as I told you, we require all the three dimensions. So other two dimension we have to extract by other means. So that other means will come in the form of cross section. Because it might happen that we have the circular shaft, or we have the rectangular beam, or we have the pipe section. In that case, though the length of the beam, pipe or bar or even the shaft is same, but the cross section is changing. So here we are simply going to create a line and the cross section might vary. So that is the beauty of 1D meshing. Under the 1D, the element shape is line and the degree of freedom per node is 6. And generally, the 1D meshing is used in order to represent the shaft, hinges, pipe, trusses, beams and most common bolted connection. Now let us move on to the 2D meshing. The 2D meshing will look something like this. Generally, whenever we have the two dimensions which are large as compared to third dimension, in that case, we will go for the 2D meshing. As you can see in the image, in case of 2D meshing, only thing that we require is the mid surface, or we can simply say instead of 3D component, we just required a surface. And from that surface only, we are going to mesh or discretize that 2D surface only. So here we have defined two dimensions, which is nothing but length and the width. The remaining dimension or the additional data from the user is nothing but the thickness of the component. So here again, only two dimension you have to define and additional data will be in the form of thickness. In case of 2D, we have the two types of element shape, chord and tria. And in case of 2D, degrees of freedom per node are 6. Application of the 2D includes sheet metal parts, plastic component, instrument panel and many of the component in the door assembly. And last but not least, 3D meshing. In case of 3D meshing, whenever we have all the dimensions which are comparable, then we will have to go for 3D meshing. Since in the meshing or the discretization itself, we are describing all three dimensions, in case of 3D meshing, we don't require any additional data from the user. In case of 3D, the element shape include tetra, hexa, prism and wedge. But interestingly, the degrees of freedom per node for the 3D element is only 3. Keep in mind the number of degrees of freedom per node available for the different type of element. Not only they will ask you this question in the interview, but this question is frequently going to repeat whenever we are going to simulate or make the connection between the different type of components. The application of the 3D meshing is numerous one. but most common one, transmission casings, engine block and piston. Another interesting thing before we end this session is that with the 3D meshing, we can represent any component. But there is a limitation in use of 1D meshing and 2D meshing. As if we have all the 3 dimension comparable, then we can't use the 2D meshing. And similarly, in case of 1D also, if we have even 2 dimensions comparable, we can't use the 1D meshing. So I hope at the end of this session, you have the little bit idea about 1D, 2D and 3D meshing. In the upcoming sessions, there will be dedicated sections for the 1D, 2D and 3D meshing. In those sections, we will take a deeper look into the various aspects of this type of meshing. Thank you for watching this video. Take care. Goodbye.